focus this afternoon is on energy. Bill Hoffman is president of Hoffman and Associates. Bill's educational background includes a Bachelor of Science in Chemical Engineering and a Master of Science in Environmental Engineering. He's a registered professional engineer with a wide range of expertise. Today, he is prepared to bring to light for us the synergies and conflicts that occur when water meets energy. Welcome, Bill.
Thank you very much. Now, if Gary didn't break this, I think I'll just go with this right here and start the program. Oops, I need to go back one here, excuse me. Energy meets water, synergies and conflicts. What do we mean by this? These are the two resources that we in this room deal with. They interact in so many different ways that it's almost unbelievable, and I guarantee you I don't know all of them, and I don't know anybody that does, but I want to show you a few of them. First place, here are a few factoids that you probably didn't know. There are 24 bills before Congress right now dealing with water efficiency, and if you look at the rise and cost of water and wastewater, it is rising 1.45 times faster than the electricity. This tells you something is going to happen out there. In the office building, in a large 10-story office building or something like this, half the water that gets consumed in the south and southwest is for the cooling towers. And maybe one that will affect most of you is as water costs rise, so will the cost of beer. So with that said and the important things covered, let's just take a look at it. Here's a quote that everybody should just remember. Water is the oil of the 21st century. That comes directly from the chief executive officer from Dow Chemical. So think about this. We have been in the energy mode since the 1970s. Sometimes we haven't done too well with it, and we're still in the energy mode. Don't forget the water mode is coming on faster, is already with us. And in fact, I like to call this the latitude of stress. If you look at the colors on there, that'll show you areas in the world that are stressed to meet the demands that are being placed on the water. For after all the water that we get in the form of fresh water ultimately originated from precipitation. It's either flowing in a river, behind a dam, recharged into the groundwater, or was recharged into the groundwater thousands of years ago, and we're now using what a term is called fossil water. So just remember that. Fresh water is an infinitely replenishable resource. We have the hydrological cycle, but it only comes at a finite rate, and that can vary. It's called drought and flood, and we have to live within this confine. Do more than that, and you are in trouble, because you can't get more out of what Mother Nature gives you. A lot of places are finding this out to be true, places that never thought of it before. And there's some interesting commonality of the reasons for this. Number one, we talk about population and its impact on energy demand. Don't forget, it has the same impact on water demand. And you can see what is happening to us. From a historical perspective, we have so many more people we had here than we had 100 years ago, 1,000 years ago, or whatever. It's just incredible. And guess what? They all need water. And which would you rather do without for 5 days? No water or no gasoline. Stop and think about that. Here's an example of what I was talking about overtaxing resources. In Texas, they get an average of course it depends on when it rains, but 4 or 5 billion gallons a day of annual recharge to the aquifers, and they're pumping 6 or 8 billion gallons out. That's doesn't take a rocket scientist to figure out they have a problem. And I could go along a lot of different places in the United States on that. So let's build more dams. Well, here is an interesting reason for taking a look back at that statement again. Look at this. This is the evaporation rate in the United States. What does that mean? And by the way, I do know how to spell Hoover, but it came out hover in here. And Lake Mead, that's what supplies Las Vegas, evaporates 1 billion gallons of water a day off of its lake surface. It is using almost a New York City's worth of water every day, just through evaporation. You build more dams, almost anything from about the middle of Texas west, and you evaporate more water than you catch in the reservoir itself. We're entering the law of diminishing returns, and the building of dams has significantly subsided in our society for a number of reasons. They talk about, well, it's environmental reasons and everything else. The biggest reason, ladies and gentlemen, is we've already built dams in the best places. They're the cheapest resources have been developed. Anything beyond this, we are in less desirable places to build, and there are just not that many more places where you can build dams. So, with this said, where are we going with this whole water thing, and how does this all tie back to energy? And I just went over some things there. Well, first place, I want to go over one other thing. This is the famous map. It was done in 2002, and it shows places that are having water shortages. And you will notice that California and New Mexico had no response, so they're not counted in the 36 states. And Nevada said, oh, we have some minor problems. And Georgia is just having some nice little problems, not anything real big. And then came 2008 for Georgia. Ladies and gentlemen, there's hardly a state out there that isn't going to face a water shortage problem not related to drought. And so we've got some things to think about. Remember, 30 years ago, people were saying the same thing about energy? Okay, we have some other things coming. First place, I want to make sure when we talk about water use that we know the difference between withdrawal and consumption. This morning, a gentleman from EPA aptly put it that, you know, or actually it was Mr. Freeman from, but water has the component of you have this stuff coming in, and then you also have the stuff going out. And what is the difference there is your consumption. And if you look at this, the biggest withdrawer of water in the United States is for thermoelectric power. It's not the biggest consumer. Irrigation is, because almost all the water you put on land for irrigation is lost again to the stream. It evaporates. It enters the hydrological cycle, but not the other. So when I talk about this, remember those definitions.